All right, so we're on to example 2. Example 2 says that solid lithium hydroxide reacts with carbon dioxide to produce lithium carbonate and water vapor. Okay. What mass of lithium carbonate will be produced when 5 grams of lithium hydroxide is used up? So again, when in doubt, we're going to want to make a chemical reaction. But how do I know that this is a molar coaster question? Molar coaster questions occur when they give you information, okay, about one chemical, but then ask you for something else about another chemical. So in this question, they give me the mass of lithium hydroxide, one chemical, but then are asking me what the mass is of a different chemical, lithium carbonate. Okay, so if I see that it gives me something and asks me for something different of a different chemical, okay, it's a molar coaster question. Molar coaster questions require, number one, a balanced chemical equation. So it says lithium hydroxide. Okay, lithium hydroxide, okay, is LiOH. You've seen that a bunch. It is a solid, and it's reacting with, I'll move it over, sorry. Lithium hydroxide is reacting with carbon dioxide, which is a gas, okay, to produce lithium carbonate. Okay, this one's a bit tricky. Lithium has a charge of +1. Carbonate has a charge of 2-. When we drop and swap, we're going to get Li2CO3. And it doesn't tell us if that's a solid or a liquid yet, but it also tells us that water vapor is being produced. Okay. Now, is this a solid, a liquid, or a gas? First off, it's an ionic compound, which means there's a metal and a non-metal. So chances are it's not a gas. Okay, could be a liquid, could be aqueous, could be a solid. But look what it asks for in the question. It asks for the mass. Okay, typically we don't measure mass of liquid mass, okay, or mass of something aqueous. Typically we would measure the mass of a solid. Okay, now if I look in my data booklet in my solubility table, okay, it's going to say that lithium carbonate, all right, is soluble. However, in this reaction, it says that it wants the mass of lithium carbonate, which even if it's soluble, it may form a solid momentarily, okay? The solubility table only happens for reactions that occur in water. Do you guys see water liquid or anything aqueous over here? Okay, no, you don't, which means the reaction is not occurring in water. I have a solid reacting with a gas, which means this will not be aqueous, it will not be liquid, it will be a solid. Okay, a little tricky, but just read the question, it'll try to help you out. Now, next thing we need this balanced. So we've got 2 lithiums over here, 1 lithium there. Let's throw in a 2. Okay, we've got 1 carbon here, 1 carbon there. That's good. We've got 3 oxygens, 4 oxygens. We've got 2 plus 2 now. That's good. 4 oxygens. 2 hydrogens, 2 hydrogens. Okay, we're done. So we have a balanced chemical equation because every element is balanced on both sides. Now, the question says, what is the mass of lithium carbonate? So it wants mass, okay? Now, mass is equal to moles times molar mass. So I know that I need moles and I need molar mass, okay? If I'm looking ahead. Molar mass, periodic table. I can do that. Moles, well, I don't know how I'm going to find those. Okay, let's think. Well, it tells me that I'm using, in this reaction, 5 grams of lithium hydroxide. Do I know the molar mass of lithium hydroxide? Okay. Well, if I think back to my 2 requirements for the molar coaster, balanced chemical equation, check. Second thing, moles of one chemical. If it gives me the mass of lithium hydroxide, I can find the moles of it, okay, by using moles is equal to mass over molar mass. And that's going to help me ride the molar coaster. So open up your data booklets. Okay, the molar mass of lithium hydroxide is lithium 6.94 plus oxygen 16 plus hydrogen 1.01. I'm going to get 23.95 grams per mole. So the moles is 5 grams, my mass, divided by 23.95 grams per mole. Okay, don't be lazy with your units. Please show them. It's going to help you guys along. Okay, now to find the moles, I'm just in my calculator going to do 5 divided by 23.95. That's going to give me 0.2087 ... moles. Okay, I'm going to put a box around that because I found it, but I will not round it. That's why I have the ... Okay, so I'm good. I have my requirements. I have a balanced chemical equation, check, and I have the moles of one chemical, check. It's asking me for the moles of something else, so I need to ride my molar coaster, all right? I'm going to divide by where I start, which is 2, and I'm going to multiply by where I'm going, which is there's nothing in front, which means 1. So I'm going to take this number, divide by 2 times 1, and I'm going to get 0.1043 ... moles. Again, I'm not done the question. Do not round that number. I then need the molar mass of lithium carbonate. So using my data booklet, I'm going to recognize that the molar mass is 6.94 times 2, because there's 2 lithium carbonates plus whatever it is for carbon, which is 12.01, plus 16 times 3, because there are 3 oxygens, and I should end up with 73.89 grams per mole. Okay? Now, if I want to find the mass, I'm going to need the moles, which I have, 1.043 ... Again, don't round that number, times 73.89 grams per mole. Moles will cancel. And if I use my calculator, I'm going to get 15.4259 grams. And with 3 sig digs, because this has 3 sig digs, that's my initial information, I'm going to get 15.4 grams. So in this reaction, that you started with 5 grams of this and you reacted it with CO2, you produced 15.4 grams of lithium carbonate.